Okay, today we're looking at more properties of exponents. Today our learning targets are that we will be able to apply the power of a quotient, exponent property, the quotient exponent property, the power of 0 exponent property, and negative exponent property. The power of a quotient exponent property is just anytime we're looking at a quotient, which can be expressed as a fraction, one thing divided by another, or one number or variable divided by another. Remember, when we have something raised to a power, that's just repeated multiplication. So when we have, last week we looked at products raised to a power. So like last week we looked at x times y raised to the 4th power, for instance. This week we're looking at the quotient, x divided by y raised to the 4th power. So what this means is that we have x over y multiplied by itself 4 times. Okay, and we know from multiplying basic fractions, when we're multiplying fractions, it's numerator times numerator. So we have x multiplied by itself 4 times in the numerator, and then y multiplied by itself 4 times in the denominator. Okay. So in exponent notation, this simplifies to x to the 4th over y to the 4th. Okay, that works with exponents. It also works with numbers. Obviously, it works with variables. It also works with numbers. Obviously, numbers are represented with variables. So when we have 2/3 raised to the 5th power, this means we have 2/3 multiplied by itself 5 times. Okay, so remember, when we're raising it to the 5th power, that's just repeated multiplication. That means that number, 2/3, multiplied by itself 5 times. So this will give us 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 times over 3 times 3 times 3 times 3 times 3, okay, which simplifies in exponent form to 2 to the 5th over 3 to the 5th. Okay, we have 2 multiplied by itself 5 times, 3 multiplied by itself 5 times. All right, then let's put these together. Let's have numbers and variables both raised to a power. And please don't forget, what's the power on this 4? When there is no power written, we know it's a power of 1. Okay, so this is 4 to the 1st power, x to the 4th power, over 3 to the 1st power, good, y to the 3rd. And when we have a power to a power, what do we do with those powers? We multiply them together. So when let's go ahead and do it as a repeated multiplication like we did here, or you could do the power to a power. But let's go ahead and look at it as a repeated multiplication, since that's what our notes are prompting us to do. So this really means 4x to the 4th over 3y cubed squared multiplied by itself. So 4x to the 4th times 3y cubed, so it's multiplied by itself. Okay, and then removing those parentheses, putting it all together, in our numerator we would have 4x to the 4th times 4x to the 4th in our denominator, we'd have 3y to the 3rd times 3y to the 3rd. Okay. And then writing that in exponential notation, we would have 4 times 4. What is that in exponential notation? In exponent notation. 4 times 4 can be written as, good, 4 squared. And then remember the product of powers property. We have x to the 4th times x to the 4th. What does that simplify to? X to the 4th times x to the 4th.
X to the 8th.
Good, because it's x times 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 x. That's going to give us x to the 8th. And then in our denominator, we have 3 times 3. What is that in exponent notation? Good, 3 squared. And then we have y to the 3rd times y to the 3rd. What does that simplify to? Very good. Y to the 6th. So nice job remembering our exponent properties from last week. Okay, we're going to leave this in exponent notation. We're not going to evaluate the 4 squared divided by 3 squared. Okay. Write down what you think a rule could be. Like if you wanted to generalize going from here to the last step, here to here, from here to here, without having to do all these intermediate steps, how would you explain that? Okay, talk with your shoulder partner. How would you, what do you think the power of a quotient exponent property is? Okay, and write that down. Take a moment for that. I'll get you started. When there is a quotient raised to a power, what do you do? When there is a quotient raised to a power, what do you do? Okay, write down what you think. Okay, and how I finished that was I said when there is a quotient raised to a power, multiply all inside powers by the outside power. Okay, and we'll look at a more formal definition of that later, but when we have power to a power here, even when we have a quotient inside, everything is going to end up getting raised to that power. Okay, so do we see how the 4 to the first power became 4 to the 1 times 2, 4 squared. This x to the 4th power became x to the 4 times 2, x to the 8th. Okay, this 3 to the first power became 3 to the 1 times 2, 3 squared. And this y to the 3rd power became y to the 3 times 2, y to the 6th. Okay. All right, let's do some sample problems together. Without doing those intermediate steps, let's take a look at number 1. We have 2/5, there's your quotient, 2 divided by 5, to the 3rd power. We can simplify this. We'll leave it in exponent notation. How can we simplify this? This will be what over what, boys and girls? What do you think?
2 cubed. 2 cubed over 5 cubed.
Perfect. 2 to the 3rd, or 2 cubed, over 5 to the 3rd, or 5 cubed. 2 cubed over 5 cubed. Okay. Number 2, we have 5/4, there's your quotient, to the 6th power. How can I write that? How can I simplify this? Good. Nice. So 5 to the 6th over 4 to the 6th. Okay. Everything gets raised to the outside power. Okay. 1/3 to the 5th power will be rewritten as what, boys and girls? Good. 1 to the 5th over 3 to the 5th. Perfect. Okay, number 4. Now, we have to be really careful with this negative sign. Okay, sometimes if the negative is inside the parentheses, it is included to what gets raised to the power. And when it's not inside the parentheses, it's not included. So I'm just going to ask you to just pause with number 4 for a moment. Okay. with your shoulder partner, and I know we talked about this last week, but it's a Monday, and I want to make sure that you remember this. So when you have this, let's do these two exponents, and talk with your shoulder partner. Are these equivalent? And if so, why? If they're not equivalent, why are they not equivalent? Talk with your shoulder partner. Use your calculator if you need to. Okay, so what do we think, class? Are these two equivalent?
No.
Okay, excellent. So what is the left-hand side equal to? Okay, this is equal to -2 multiplied by itself 4 times, right? So this is that. Whereas this, we have the opposite of 2 to the 4th power. We have the opposite of 2 to the 4th power. So this is negative 2 times 2 times 2 times 2. So the exponent, remember, the power, only applies to whatever's right before it. So in this case, the 4 only applies to the 2. Only the 2 is getting raised to the 4th power. Here, -2 is getting raised to the 4th power. Okay, so what's a negative times a negative? Times a negative? Times a positive. Good. So again, that was a negative times a negative. These two will give us a positive. And then we multiply it by a negative, which gives us a negative. And then we multiply that by a negative, which gives us a positive. Right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So on the left-hand side, we end up with a positive 16. On the right-hand side, we have -2 times 2. What's that? What's -2 times 2? -4. -4 times +2. -8. -8 times +2. -16. And if you don't believe me, you can even ask your scientific calculator to help you out with that, okay? These two are not equal, okay? They are not equal. Here, the -2 gets raised to the 4th power. Here, only the 2 gets raised to the 4th power. So we're looking at the opposite of 2 to the 4th. Here, we're looking at -2 to the 4th power. So there is an important difference there. You have to remember that that exponent only applies to whatever is immediately before it. All right, so now that we just clarified that, let's look at number 4 again. So here we have -2/3 raised to the 4th power. So is that negative included in this case? Is it inside the parentheses? Yes, it is. And that's getting raised to the 4th power. So it is -2 to the 4th over 3 to the 4th. All right, and we're not going to evaluate that. We know that our answer is going to end up being positive. We have a negative raised to an even power. We talked about even powers of negatives give us positive answers. Okay, number 5. H over G squared. What will this simplify to? H squared over G squared. Nice job. Number 6. D over C, all to the 7th, will simplify to what, boys and girls? D to the 7th over C to the 7th. Nice. Okay, 7. We have V to the 2nd to the 4th, or excuse me, V to the 2nd to the 2nd over W to the 3rd to the 2nd. So this quantity gets, or this quotient, gets raised to the 2nd power. So what do we end up with? In our numerator, we will have V to the 2nd to the 2nd. What do we do with those powers? What do we do? What's the operation? Multiply. Okay, so 2 times 2 is 4. Okay, and then what's V to the 3rd to the 2nd? W. W to the 3rd to the 2nd is W to the 3 times 2, W to the 6th. We're multiplying. When we have a power of a power, we multiply the exponents. That's from last week's property. 8, x to the 5th over y to the 4th, all to the 4th. We end up with what, boys and girls? X to the 20th over
Y to the 16th.
y to the 16th. Okay, we multiply. I heard a couple people say 9. Remember, x to the 5th times x to the 4th would give you x to the 9. Right, boys and girls?
Yeah.
But x to the 5th to the 4th means we have x to the 5th times x to the 5th times x to the 5th times x to the 5th, right? It's this number multiplied by itself 4 times. That's x to the 20th, okay? So remember that difference. So I'll just leave that there. Okay, number 9. What's the power on our 4 right now? 4 to the 1st. Remember, only the x is raised to the 5th power. This has a power of 1. When there's no power written, we understand that it's to the 1st power. What's the power on my 3? Right now it's 3 to the 1st. Okay, then everything gets raised to the 6th power. So that means I have 4 times 4 times 4 times 4 times 4 times 4, or 4 to the 6. 4 to the 1 times 6, 4 to the 6. Here I have x to the 5th multiplied by itself 6 times. So that's going to be how many factors of x? X to the what, boys and girls? It's a big one. X to the 30th, right? Because that means I have x to the 5th times 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 x to the 5th. That x to the 5th gets multiplied by itself 6 times to give me x to the 30th. Okay, 3 is just to the 1st power, and then that gets raised to the 6th power, giving us 3 to the 6th. We have y squared to the 6th. What will that give us, class? Y to the 12. Nice job. We're going to leave it in exponent form. All right. On page 2, we're going to look at the quotient exponent property. All right. Now we're dividing variables and numbers. If we're looking at x to the 10th power, what that really means is 10 factors of x. X multiplied by itself 10 times. When we have x to the 4th, that means we have x multiplied by itself 4 times. 1, 2, 3, 4 factors of x. Now, if you think back to your elementary arithmetic, it doesn't matter what x is, so just forget about x for a moment. What is any number, let's just say 5, divided by itself? Good. What's any negative number divided by itself? Right, a negative divided by a negative is a positive. Okay. What's any rational number? Let's do root 4 divided by root 4 divided by itself. Okay, what's the square root of 4? 2 divided by 2. What is that? 1. What's any irrational number divided by itself? Pi divided by pi is 1. Any number divided by itself is 1, except 0 because we cannot divide by 0. But any other number divided by itself is 1. So when I look at this, x, 10 factors of x divided by 4 factors of x, I know that I have some mathematical simplifying to do here. So x divided by x will give me 1. X divided by x gives me 1. X divided by x gives me 1. X divided by x gives me 1. It's written here. I just wanted to let you see what that meant. So in my numerator, what am I left with? Let's use this as our fraction bar. That's what they're doing here. I'm left with x times x times x times x times x times x. I'm x times x times x times x times x times x. And then what am I left with in my denominator? 1 times 1 times 1 times 1. What is that? 1. So what does this simplify to? X to the 6th. I don't need to say over 1. Okay, it's just x to the 6th. What do you notice about the exponents?
exponents or like?
What do you notice about the exponents here? We have x to the 10th, x to the 4th, x to the 6th. Faith? Good. Nice. You subtracted them, right? Because these 4 in the denominator canceled out with 4 of the x's in the numerator. And we ended up with x to the 10 minus 4. X to the 10 minus 4 is x to the 6th. All right, let's try that again and see if that is going to hold true for example 2. So example 2, we have y to the 7th divided by y. Y to the 7th means y multiplied by itself 7 times. Divided by just y. Okay, so I want to simplify. What's y divided by y? 1. Any number divided by itself is 1. So what am I left with in my numerator? Y times y times y times y times y times y. What is that?
Y to the 6th.
Good. And they all divided by, what was left here? 1. Okay, so I have y to the 6th over 1, or just y to the 6th. What do you notice about the exponents with this number, this example 2? Example number 2. Okay, what's good? I heard somebody say you subtract. Nice job. What's the power here? What's the exponent on the y here? 1. So we have y to the 7th over y to the 1, and that's simplified to y to the 7 minus 1, which is y to the 6th. Okay, and this should make this, what we're discovering here is the quotient exponent property. And that should make sense because remember last week we looked at, let's do to the 3rd here. Like just jot this up in the upper margin here. X to the 2nd times x to the 3rd equals, and then what did we say last week? We didn't have to multiply this out, repeated multiplication, x times x times x times x times x. Then simplify. We said, what can we do? We discovered, what are we allowed to do with those exponents? Right. If you have, when you're multiplying like bases, so the base is x, they are alike, we're multiplying them. We're allowed to do what with the exponents? You just said it. Add them. So doesn't it make sense that if when we multiply like bases, we add the exponents? When we divide like bases, we should subtract the exponents. Okay, so that just makes sense following our logical patterns. So this is, again, if you have y to the 7th over y to the 1st, it'd be y to the 7 minus 1, or y to the 6th. Okay, let's look at example 3. Now we have some coefficients. Okay, don't be intimidated by that. You've been doing this since elementary school. This is just simplifying fractions, right? Or dividing. What's 48 divided by 6? Or what's 48/6 written in lowest as a simplified fraction? Okay, 48 divided by 6 is 8. Or if you wanted to simplify the fraction, right, you say, oh, those both have a common factor of 6. Okay. 48 divided by 6 is 8. 6 divided by 6 is 1. Okay, so this is 8 over 1. I'm not going to write the 1 in the denominator. I already have some other things there, so I'm just going to leave it for now. Okay. And then let's go ahead and look at x to the 8th over x to the 5th. So I'm just going to do some thinking out loud over here and writing it over here. When I have x to the 8th over x to the 5th, doesn't that just mean, okay, and some of you were already using your property, and that's awesome. I'm going to go a little slower with this problem for now. Okay, that means 8 factors of x divided by 5 factors of x, right? What's x divided by x? 1. X divided by x? 1, 1, 1, 1. So what happens is these 5 x's cancel out or divide out. 5 of these 8 x's, right, boys and girls? These 5 x's cancel out with 5 of these 8, leaving me with how many? 3. X times x times x, right? Or if you wanted to use your property, exponent property, it's x, quotient exponent property, excuse me, it's x to the 8 minus 5, x to the 3rd. And that is, those three x's are left, those three factors of x are left in the numerator. So if we look back at this problem, x to the 8th over x to the 5th. So you can visualize, you don't actually need to write them out. You can visualize, you have more factors of x in the numerator. So these 5 factors of x will factor out with 5 of these 8, leaving you with 3. So x to the 3rd. And what will happen here? You have 12 factors of y. Y multiplied by itself 12 times, divided by y multiplied by itself 2 times, right? So these 2 factors, y times y, will cancel out with 2 of these, leaving you with how many? 10. So y to the 10th. All right, let's just do the odds on this bottom part of the page. Number 1, we have 8 to the 9th divided by 8 to the 7th. That's going to give you 8 to the 9 minus 7, which is 8 to the 2nd. We're going to leave it in exponent form. Okay. Number 3, we have 12 thirds. So as a fraction, can I simplify that? It's a division problem, right? 12 divided by 3. What is that? 4. Okay. 4 to the x. So we have x to the 4th divided by x to the 3rd. So that's x to the 4 minus 3. So that's 4. What's 4 minus 3? Just 1. 4x to the 1st power. Do I need to write the power of 1 on this x? I do not. Okay. X to the 10th over x to the 6th. That's going to be x to the 10 minus 6, x to the 4th. Okay, if we want to visualize 10 factors of x divided by 6 factors of x, 6 of these will cancel out with, these 6 factors of x will cancel out with 6 of these, leaving me with 4 factors of x. Okay, number 7, we have a to the 7th divided by a to the 3rd. 3 of these a's will cancel out with 3 of these a's, leaving me with a to the what, boys and girls? Good, a to the 4th. So we had a to the 7 minus 3. Write this intermediate step because we're going to encounter some negatives in the second part of these notes. And we're going to want to know that intermediate step because we're going to end up with some negative powers pretty soon, okay? So even though you can do this in your head, I want you to write it down because when we get to negatives, I want you to be able to be better able to visualize that. So it's a to the 7 minus 3. A to the 4th. Okay, 4/8. We know that that simplifies to 1/2, right, boys and girls? 1/2. Then I have a to the 15th over a to the 12th. That's going to be a to the 15 minus 12. Okay, or a to the 3rd. Okay, I'm going to write that a to the 15 minus 12 in my margin. A to the 3rd. Okay, these 12 factors of a will cancel out with 12 of these, leaving me with just 3 in the numerator. Okay, and one more. We have 9/27. That can be simplified. 9 and 27 are both divisible by 9, right? 9 divided by 9 is 1. 27 divided by 9 is 3. So I have 1/3. I have x to the 8th over x to the 5th, right? 5 of these x's cancel out with 5 of these x's, leaving me with 3. So x to the 3rd. Do I need that coefficient 1? No, I do not need that coefficient. All right, and if you remember back to last week, we did look at, just want to refresh your memory. Do you remember doing this last week? Looking at all the different powers. So we looked at 2. When we just have 2 to the 1st power, that's 2. 2 to the 2nd is 2 times itself, 4. 2 to the 3rd is 2 times 2 times 2, 8. 2 to the 4th is 2 times 2 times 2 times 2, 16. All right, and then we added on this next level. We went from 2 to the 0. We followed this pattern to help us understand, or excuse me, we went from 2 to the 1st. We added on 2 to the 0, and we tried to figure out what that would equal. So we notice that as we decrease the power of 2 from 2 to the 4th to 2 to the 3rd to 2 to the 2nd, each time we were dividing by 2. 16 divided by 2 gave us 8. 8 divided by 2 gave us 4. 4 divided by 2 gave us 2. Okay, if I take that 2 and divide it by 2, I get 1. 2 over 2 gives me 1. Okay, so any number to the 0 power will always equal 1. So if I had 3's here, right, I would have 3 times 3 is 9. Divide that by 3, I would get 3. I would have 3 over 3, which would equal 1. If I had powers of 4, I would have 4 over 4 here. That would equal 1. If I had powers of 5 here, I would have 5 over 5, which would equal 1. Any number raised to the 0 power is 1. Anything raised to the 0 power is 1. Okay, so then we continue on into our negatives. We talked about this last week. Now we're actually going to use it in our problems today. So if I continue this pattern of dividing by 2, dividing by 2, dividing by 2, what's 1 divided by 2? 1/2. Okay, so 2 to the negative power is the same as 1 over 2, or 1 over 2 to the first power. Okay? But I'm going to leave that as 1 over 2. I'm also going to write it as 1 over 2 to the first. Okay, so that's the reciprocal here. See how I put them both in blue? Okay, what about 2 to the negative second? I take that half from 2 to the negative first power, and I divide it by 2. How do I divide when I'm working with fractions? To divide by 2, I multiply by its reciprocal, so times 1 over 2. I take my number here, I multiply it by 1/2. 1/2 times 1/2 is 1/4. So 2 to the negative second power is half times half, okay, which is 1 over 2 squared, which is 1/4. Okay, then, if I divide that by half, okay, that's the same as multiplying, I'm going to leave this instead of 4, I'm going to leave it as 2 squared, so we can see those powers, those repeated powers. Okay, now I have 1 over 2 squared times 1/2, which gives me 1 over 2 cubed, which is 1/8. 2 to the negative 4th is this previous answer, 1 over 2 cubed. I'm just going to take that 8. It's the same thing as 2 cubed. I just want to emphasize these powers of 2. Okay, 2 to the negative 4th, we take that previous answer, 2 to the 3rd, and divide it by 2. How do we divide by 2? Multiply by its reciprocal, times 1/2. This gives us 1 over 2 to the 4th, 1/16. Okay, so we're going to continue on. I know we're going a little over schedule, but we're doing really well, so we're going to go a little bit farther. So look back to the notes. This is just a refresher with 0 powers and negative powers from last week. Okay, now we're going to take away the numbers, okay? And we're just going to look at that same concept with variables because we need to be able to apply this algebraically as well. Okay, so what's our coefficient? If there is no written coefficient, we understand that the coefficient is what? 1. Okay, so we have 1 times A times A times A. Okay? A squared is 1 times A times A. So each time what we're doing is we're dividing by A. So if you can think of this A times A times A, dividing it by A, what happens? A divided by A is 1, leaving you with just A times A, your A squared. So again, we divide by A. Each time we decrease the power by 1, we're having 1 less factor of A. Okay, so what is just A? It's 1 times A. If we divide by A again, what do we have? 1. Okay, we have 1 times A. We're dividing by A, so if you can imagine 1A divided by A divided by A is 1, so I just have 1 times 1, which is 1. Okay, and then again, I divide by A. Oops, divide by A. What's 1 divided by A? 1 divided by A is 1 over A. Okay, I'm decreasing by another factor of A. I divide by A again. Okay, I had 1 over A. I divide by a again. How do I divide with fractions? Multiply by the reciprocal, 1 over a, 1 over a. And I end up with 1 over a times a, which is 1 over a squared. We'll leave it as 1 over a times a. I'm going to put it over here, 1 over a squared. 1 over a squared. I want you to understand these are equivalent. A to the negative second power equals 1 over a squared. These are the same thing. A to the negative second power is equal to 1 over a squared. A to the negative third power, I take this and I divide it by a, okay, which is, how do I divide by a? Multiply by the reciprocal, 1 over a, so I end up with 1 over a times a, which is the same thing as 1 over a to the third. So please understand that a to the negative third power is equal to 1 over a to the positive third power. And that's important to know because in algebra, we always like everything simplified. Okay, do negative exponents look very simplified? No, negative exponents are complex. We do not want to have negative exponents. If you have a negative exponent, your answer is not simplified. So when you have a negative exponent, you can remember this chart and remember this fact that if you have a to the negative second, that's not simplified. So if you want to write it as simplified, you need to move that negative exponent, that base with the negative power, to the denominator. Okay, so a to the negative second in the numerator, I can rewrite it as 1 over a to the positive second. Okay, and the opposite holds true as well. If you have a negative exponent in the denominator, you can move it to the numerator and it'll become a positive exponent. Okay, I'm going to summarize this for you. Any base raised to the power of 0 equals 1. Any base raised to the power of 0 equals 1. And for negative exponents, if there is a negative exponent, take the reciprocal of the base. That has a negative exponent, or take the reciprocal of the base with the negative exponent. And we'll look at a more formal definition of that later, but let's do some application problems. So if I have 1 over a to the negative fourth, I don't want a negative exponent. I'm going to move my exponent to the numerator. So my a to the negative fourth, when I move it to the numerator, it's going to be a to the fourth. Okay, so 1 over a to the negative fourth is equal to a to the fourth. Okay, what's the power on my 2? Over here. 2 to the what? 2 to the first. Okay, that's a positive exponent. It's good where it is. This can stay where it is. Now, I have 3 to the negative third power. That is not simplified. I do not want a negative exponent. How do I make it positive? I move it from the denominator to the numerator. So 3 to the negative third can be written as 3 to the third. Okay, so, sorry, 1 over 3 to the negative third can be rewritten as 3 to the third in the numerator. So move it from the denominator to the numerator. You guys are doing great. Okay, we're going to look at the odd problems on this page. Some of these get a little bit more complex. let's do our conclusion and then first, and then we'll come back to this page and do as many sample problems as we can before lunch, okay? So let's look at our conclusion, and we'll do some application problems. Today we learned how to apply the power of a quotient exponent property. The quotient exponent property. Okay, power of 0 exponent property. And negative exponent property. All right, so when we look at number 1, we have 8 to the 7th divided by 8 to the 9th. So when we're dividing powers with like bases, we can subtract the exponents. So this is going to give us 8 to the 7 minus 9. Okay, what's 7 minus 9? Negative 2. So what we have is 8 to the negative 2. Is that a simplified answer? No, it's not. We cannot have negative exponents. So to make it as simplified as possible, we're going to take this 8 to the negative 2. It's currently in the numerator. We're going to move it to the denominator. And it's going to change from being 8 to the negative second power in the numerator. It's going to be 8 to the positive second power in the denominator. What's left in my numerator? 1. Okay, we're going to do the odds. Number 3, we have 12 thirds. 12 thirds, these are both divisible by 3, right? 12 divided by 3 gives us 4 over 1. Now I have x to the third divided by x to the fourth. This is x times x times x. This is x times x times x times x. 3 of these x's will cancel out with 3 of these x's, leaving me with how many? 1x in the denominator. Okay, so again, this was x to the third. So if you can't visualize what I'm saying, just write it off to the side here, x to the third over, this was x to the fourth. And then they would cancel out because any number divided by itself is 1. X divided by x is 1. X divided by x is 1, leaving us with 1x in the denominator. Okay, so what's in my numerator? Just the 4, right? 12 thirds simplified to 4. And then what about my x's? I had x to the third over x to the fourth, right? These 3 x's cancel out with 3 of the x's, factors of x in the denominator, leaving me with just 1x in the denominator. So we have 4 over x. Okay, number 5 is the simplest problem on the whole page because anything to the 0 power is 1. So I don't even need to calculate what this is. I know that anything to the 0 power equals 1. Okay? By the way, what would it be? We would move these to the denominator, and they'd be x to the 6th, and then we'd have x to the 10th times x to the 6th, so it'd be 1 over x to the 16th, right? But that didn't really matter because when we raise it to the 0 power, it just equals 1. So you can skip this middle step if you wish. Anything to the 0 power equals 1. Okay? You have a couple ways you can think of this number 7. You can either change all of these to change these negatives to positive. You can put them in the numerator, right? So I can say a to the third over, this is a to the negative seventh, but I want it to be positive seventh, so I move it to the numerator, okay? And that's over 1. That'll give you a to the 10th. That's one way of doing it. Or you can say, there's your answer, one method. Or you can say, oh, a to the third divided by a to the negative 7th is going to be a to the 3 minus negative 7. What's 3 minus negative 7? A to the 10th. Either way, whichever way you prefer to think of it, is totally personal preference. You get the same correct answer either way. All right, I'll do this one with the quotient property here. This is a to the negative 5th divided by a to the negative 12th. That's going to be a to the negative 5. That's my power in the numerator. Minus negative 12. Okay. Minus negative. You can change that from never subtract. Add the opposite, right? This will give us a to the 7th. Okay? All right, and then alternatively, you could take all these a's, put them in the numerator. It'd be a to the positive 12th, and then you would use the power of products property. Anything to the 0 power is 1. Okay? Now we have a couple ways we can do this. We can divide it out first and then raise that to the second power, or we can raise everything to the second power. Let's go ahead and raise everything to the second power because we haven't used that approach yet. So we have v to the 4th to the 2nd, v to the 4th to the 2nd, that's going to give us v to the 8th, over v to the 7th to the 2nd, that's going to give us v to the, good. And then 8 of these 8 v's, okay, we'll cancel out with 8 of these v's, leaving us with 1 over v to the 6th. Okay. All right, so let's look at the last one. Yeah, we're doing okay with time. So here, I'd probably simplify inside first before you raise anything to the 6th power. That's how I would approach this problem. But you can absolutely raise everything to the 6th power and then simplify next. It's totally personal preference. I'm going to simplify inside first. Okay, so 4/3, I can't simplify that. It's a 1/1/3. Can't do anything with it, so I'm just going to leave it as 4/3. Okay, I'm looking at my x's, and then all of this is going to end up getting raised to the 6th. Now I'm looking at my x's. I have x to the 5th, that's good. And I have x to the negative 2nd, that's a negative exponent. So I'm going to move this up to the numerator as x to the 2nd, right? So I'm going to take this, move it up here, times x to the 2nd, not power of x to the 2nd, just times x to the 2nd. What's x to the 5th times x to the 2nd? X to the 7th. And then I'm looking at this y. This jumps right out at me because anything to the 0 power is 1. So this is just all over 1. Okay. And then I have my y squared. And then all of that gets raised to the 6th power. So I end up with 4 to the 6th times x to the 7th to the 6th, x to the 42nd, and y to the 2nd to the 6th, y to the 12th, over 3 to the 6th. Okay? And you'll have several practice problems tonight that you can practice these skills on, and we will check them together tomorrow. Outstanding job this morning.